Welcome to TARCTalks. In this episode, filmed September 21st, 2020, Jim AA4MD discusses Earth-Moon-Earth communications, also known as Moonbounce.
Well, my call sign is AA4MD, Jim, and we're going to talk tonight about Earth, Moon, Earth. And this was completely unknown to me prior to about 4 years ago. And I'm not really sure, I'm just trying to think back of how I got into this in the first place. But I don't know, I guess it was just like, it's really the Mount Everest of ham radio. Having done a lot of hard things in radio, this turned out to be the hardest. And so I'll take you through that story a little bit just for fun. And not to discourage anybody, because it's really special, but it did take me about 2 years to get all the crazy garbage that I put up trying to hear the moon to get started. And I guess that's one way, if you really don't have somebody who's done it before real close by, you just have to kind of feel your way along and make a lot of phone calls to guys to get some help. Here's a picture of this week's contest, the Italian EME contest. Up here, you're going to see a signal PI9CAM. He's operating a 25-meter dish and very low power, and has a signal, as you can see, that's just unbelievable. Here's my CQ. You'll see at 1296.080 with the Doppler shift programmed in over here for transmitting back. Oops. Here's the JT65C WSJT part of the program. Here's the amplifier at 600 watts at 1296. And then that's the flex, and up above the rotator, the alpha spin rotator in as and L. And here's the blog of the guys who are on. So here's a list of all the guys who are on 1296 during this contest at one particular point in time. Let me just pause here for just a second. Maybe anybody have any particular comments about this or something I could clarify. I'm sure many of you have done digital contacts. This is on JT65C, but many of you, I'm sure, are doing FT8 and this kind of thing. Any thoughts or comments right now? So that's kind of what I did last weekend. And I thought I'd summarize for you the contest I was in, and then take a walk back in history as to how that station got started. So the contest results from this weekend, I had 10 Morse code QSOs, which are particularly difficult from the moon because you have to have a pretty big signal for somebody to hear you audibly. Normally just the digital picks it up. So I was very fortunate to get that. And then 17 digital QSOs, like you saw me trying to make there. And in this contest, you get a multiplier for every Italian you work. So I was able to work 6 different Italians. So I was real proud of that. It doesn't sound like very bodacious numbers, does it, for contest numbers? But hey, you know, that just tells you a little bit how hard it is. Well, this is my wife of 5 years, and Nan and I were married a little while, and she said, what's that thing sitting out in the garage there, you know, with the dish sitting out by the house and the stand there? I said, oh, that's something, you know, that's my bucket list. I said, it's for shooting the moon. And then Nan made the mistake of saying, hey, let's shoot the moon. Well, that was the beginning of it, that's for sure. And I had to make a choice then. How was I going to shoot the moon, you know? So I'd been thinking about it and thinking I would use the dish from the satellite work with AA4MD and see if maybe that would work. As you can see here, you'd have to go a little bit bigger here, as this guy did. And this, I think he was working in the higher frequencies, 1296 and up. This guy decided to use 1296 in the mobile, okay? So how many, 1, 2, 3, 4, 5, I don't know how many Yagis he's got there, but he goes in the mobile and steers that thing to the moon and tracks the moon and makes contacts from various places. So he's a very popular guy. Now here's a guy who just went out and put up a tripod, and that looks like about, you know, 432 actually. So 432 is very common, and 2 meters also, a very common bands for EME. And we'll talk about what I'm doing, which is 1296 later, and some of the reasons that it is a good place to start if you're thinking about trying this. Well, why 1296? Well, it was the first ham band where the Faraday polarization shift becomes negligible. Now, Lou is going to explain that to us later on, what that means, but just suffice it to say that you have to kind of change polarizations like on 2 meters if you're going to hear the guy. Sometimes you hear it one way, sometimes you hear it the other way, just like on the satellites when we rotate our little handheld antennas to try to get the best reception. The lowest ham band in which galactic and solar noise are at a minimum, so the noise factor turns out to kind of be just about right on 1296. It's the highest band on which a received noise figure is, I'll just flip this over here, is possible the highest ham band where tubes capable of kW input are available. And nowadays, you'll find out that most of the amps are solid state now. It's very quickly moving to solid state amps. And it's the only ham band where we're definitely assured that a competent and reliable group would be duplicating our efforts on the other end. You want to pick a frequency to talk to guys on where there are other guys who are equally crazy as you are. So we're using circular polarization by and large. So the horn that I was telling you about has the characteristics inside of it that make the signal go up right-handed and then come down left-handed. And this is pretty much the standard. Single Yagis, I talk to single Yagis now and then, or dual Yagis, a couple of guys were on, and just barely make it with good power this last weekend. But as a rule, most guys are using this horn with circular polarization. And nowadays, I'm getting about 400 watts up to the antenna using an amplifier by W6PQL, which is a solid state amp, 600 watt amp that you saw there, but I lose about 200 watts in the feed line. So if you really want to have a good antenna, as you all know about UHF frequencies, it's best to put the amp right behind the dish. Not a very pleasant thing for me to anticipate right now. So for those reasons, I would posit, but others might disagree, that EME is the best choice for a beginner. Now here's our friend, the dish that Warren and I were using, and the dish that I used on AA4MD. These are kind of handmade discs that I'll mention to you that, create the energy. I was listening on 432, or rather on 1.2 gigs, and transmitting on 432. And so this is you didn't have to be too worried about where it was pointing. So you used an actuator here, and I had a motor that was turning the thing with a chain down here. And that worked out pretty well for AA4MD. Here's another picture of it from the back, reminding you that this is where the motor was placed here and turning the thing with the chain. And sometimes you had to go up and read the elevation off of the little elevation meter, and other times you'd be more or less where you wanted to point. And so I tried this actually with those elements, and with this dish, I actually did hear the moon signal on 1296 one afternoon. Mike Springer was over, W4UOO, and his son, so I have witnesses that there was actually a signal coming down into my radio, which was an SDR radio at the time, listening on 1296. But I could tell this was just not going to work. Number one, you have to be in about 1 degree angle, accuracy, if you're going to have a talk on the moon. And then it moves, as you all know, and so as it moves, you have to track it. And here's the close-up here of those elements, which I was kind of proud of this when it was working, but this was not going to be an adequate deal for Moonbounce on 1296. So the next iteration was a 12-foot dish that Stan WA4NFY helped me find in Orlando. We hauled it over on the trailer, put it in the front yard, and had to weld a bracket on the back of it and start giving it a couple of coats of paint. All the neighbors wanted to know, what the heck is that out in the driveway? Now, it's kind of a fun thing to do. And then we had, at the time, we had already acquired this this horn, okay, and you have to put the horn right at the right spot in the, the focal length of in front of the dish. And Ronnie LeBrun here is doing the hard work. Well, some of you can't tell from this picture. I'm the guy on the ground here, and Ronnie's up there, but you can't tell. But we had to put another tower up next to this tower that's going to wind up on to use it as a gin pull so that we could actually get this thing. This thing is heavy, and negotiating this as we went up here was a real piece of work. Somehow you never think through these things all the way to the end. You do one step at a time. And boy, this is a great example of that. You might see what my counterweights were here. On my initial counterweights, a couple of bricks, if you don't have the counterweight exactly right, an alpha spid rotor has no chance of going from 90 degrees all the way down to 0 degrees because of all the torque that comes in at different points in that tail. The azimuth turning was not as difficult, but this you can probably see I got a couple of weights off the end of your weightlifting thing and a couple of bricks there at the time. And to make a long story short, that just didn't work very well at all. The wind would blow and the weights were swinging in the breeze, and it just was ugly. Well, this was the final product of all this effort. You can see that I used a little cake pan. It's a handy dandy cake pan that I got off the internet that you cut and you mount it and make a scalar ring out of it around the horn, so that focuses the energy more on the dish. You'll notice here that this is Ronnie was able to get me a piece of tugboat axle to put on the back there, and it looks like a little more substantial arm coming back here now, and you can adjust it. And so I've got it so it doesn't jam up or forget to go now. It'll just, the amperage it'll draw from your power supply. I monitor actually, because if you've got it going in two directions at once, you'll get up at 6-7 amps of draw from that power supply. So anyway, this was the way it went. And then up on here is one of those low noise amplifiers, LNAs for 1296 that I mentioned to you from W4GGK in England, and he was making these. Then obviously you have to have some way of kind of aiming the thing at the right place. Well, that takes a little doing. Maybe you put a laser inside of it and aim it over here, and then adjust it and try to get it at the right distance, the focal length. And it just turns out to be, just one thing after another. But anyway, this was close to the final thing. Then I started to hear some signals and started to learn how to use the software. If anybody who's used WSJT, you know that it can be a little challenging sometimes. And it's particularly challenging if you're trying to adjust the Doppler. Remember, the moon is either moving towards you early in the pass or going away from you after it passes overhead. So then you have to, so the software does adjust for that Doppler shift if you set it right, if you get it, if you set your transmitter on a split frequency at that different frequency so as to hear your own echo in a predictable place. So when I call CQ on the moon, remember it's a 3-second round trip for the signal to get back. As I send all that energy up, and this is about 30 dB of gain just with the dish, I have to overcome a 270 dB loss. So the energy goes up to the moon, about 7% only is reflected back. And as you know, the moon is a little irregular, so it's reflected back in some what's called libration, which doesn't affect the signals much on 1296, but other frequencies it really does. So then you want to try to transmit and then listen, and then you conduct a digital contact. Now in Morse code, it's kind of cool because you have to be able to hear your own echo, obviously, to work somebody and figure out where you are, and then put your signal on his. And maybe in a way, it's just a little more straightforward. Well, Mike brought his little analyzer over, and we finally got the horn tuned up here, so to speak, and doing the right thing and with some of the characteristics that we were looking for. And then the next thing you do is to aim the dish at the sun. And so you always have the coordinates of the sun stored in your computer. And if you click on a sun, it'll aim at the sun. First thing you know is whether or not it's your aiming system is working. because if you look at the dish, if you can see into the dish, it should make a perfect shadow right in the middle here, okay? So you should see the shadow of the horn as a perfect circle if you're aimed exactly at the sun. Well, that's helpful. That's kind of a double check. Also, you peak up, you move it around until you peak up the signal coming back. And my system, like it is here, theoretically should make about 13 dB of sun noise. I get consistently about 10 dB of sun noise. At least you know then that your receiver is working and that you're able to point in a predictable direction. Well, you know, if you think you're predicting in the right, you're pointing in the right direction as the moon comes up and comes over, well, then it's slightly different when the moon comes back and goes back over to the west. And you might say, well, gee, your climber, you know, gave you a half a degree of inclination on the boom. Well, that's all it takes, right, for you to be off 1 or 2 degrees. So you have to then program in these adjustments in the mechanical problem of pointing, depending on where you're pointing elevation and azimuth-wise. So that takes a little bit of doing to get that part to work. Obviously, all this can fall apart if, like Bruce was mentioning, if you blow your preamp, or if the wind is blowing, and this thing is like a big sail, as you can imagine, that has tremendous torque on it in the wind. Well, here's an example of a program. I just wanted to let you know, if you're interested in this and you'd like to kind of look it up a little bit, there's a program here called the EME planner, and I'll show you a little bit more about that. But just to give you an idea of what you're thinking about, let's say that you live in my QTH here, Echo Lima 87, and you want to talk to a guy in Spain. Well, you might just get on there and say, you know, CQ Spain, or you might send them an email and say, let's get on at a certain time. Or, but first of all, you got to figure out when Spain and you are both seeing the moon, right? So, and this is a good example. If you start up here, this is for the 21st, which is yesterday, I think. Or wait, no, it's today, yeah. So this is for today. And at noon today, you notice that my elevation, my moon elevation, was 1.2 degrees. So the moon came up right around noon today, and then it kept going up, and I'm just going to use my pointer. I hope you can see that. And then it goes up, and here we are at 1900 minus 4 is about 4 o'clock in the afternoon. About 5 o'clock, okay, it's up to about 42 degrees. All right, so that's not too bad. Well, what was happening on the azimuth during that time? Well, on the azimuth, it started out around 111 degrees right over the airport where all the good QRM signals are, all the radar signals, the guys are. And then you rotate around counterclockwise from east all the way down to south, and then you almost get pointing south, 106, 170 degrees by the time this elevation went up to 42. Well, what's happening in Spain at the same time? Oh, well, he's at 32 to start, right about, because the moon has already been up for 3 or 4 hours over at his QTH, and he goes down. So he's losing the moon, going down to 1 degree at the same time that you're going up to 40 degrees. So just give you an idea, that's kind of the thing you have to think of. Well, in contests, that's a real big deal, right? Because so the Europeans have a 3 or 4 hour jump on you to work each other and get all kinds of points while you're waiting for the moon to come up. And then by the time it gets around to the west, they're gone. They're long gone, and you're hoping that somebody in New Zealand or Australia or Japan will come on, and that happens sometimes, and other times it doesn't happen. Here's just another fact of what's going on here in space. Remember, you can get the moon, and you can get where the sun is kind of automatically, but all these are star formations, if you will, and obviously planets. And some of these, the moon, in fact, has a certain amount of radio noise that comes from it. So if your system's really working and you've got 10, 12 dB of gain on the sun, you can actually pick up about 1 dB of radio noise coming off the moon if you're watching as a way to tune into it. And then obviously much less reflection coming off of the various star systems and such. But I thought I would just pick your interest a little bit with that idea. Now here is the program, and it's if you want to write it down, it's VK3UM, the EME planner, and that's the program I'm showing you. There's another one called the EME calculator, which allows you to calculate you put in how much loss you have, how much power you're using, what dish you're using, and you can actually calculate how much, what kind of sun noise numbers you're supposed to get and whether your system is working or not. And the other thing everybody I think is aware of already is that you really, if you're using a digital mode like WSJT, you have to have your right to the second. You have to be on GMT time. And I use the Mindbird program. There are others, many others you can use, but that's the one that's been reliable for me to make sure that you're on the right time of the other guy. Remember, JT65 is about a 20-second transmission. Then there's a little break, and then there's a 20-second listening period that goes in. So it's a full minute for back and forth using JT65 in order to get the, you get about 30 dB of improvement on your signal by doing that method. Well, you might say, well, gee, sometimes the moon is there, it looks good, and sometimes it doesn't look very good. Does it matter if it's full or not? Well, in fact, it's not so much of whether you you have a full moon or whether you have a crescent moon or whatever, but what's important is where the moon is with respect to the Earth. And this is something that took me a while to try to figure out. What is the moon declination? Well, basically, when the declination is minus, that means that the moon is below the equator. And so for us stations in the northern hemisphere, it's not very good. It's not going to be optimal conditions. When you see the moon start to come over zero and go into a positive declination, you know that's going to be a good time. And you can see here that the best time this month peaked up right around 12th or 13th or 14th, and wasn't too bad in the contest period. It was still going down. It got to be about -8 by the time we were done with the contest. But just to give you an idea, the kind of the variables that you're looking at. So you can go on this planner and it'll show up in green when you and a guy in Italy, for example, are good with each other, partly related to these kinds of things. South America obviously will be a different thing. Was there a comment or something you wanted to mention about this? So a lot of things, you didn't want to know about the moon, I guess, but if you're going to bounce a signal off it, you got to start thinking about it. Now, this was an introduction by the fellow here who wrote this program, and this all kind of dates back to 1960 or so, when the first signals were bounced off the moon. He was introduced when computers came out in 1968, and so he was just kind of gives a little bit of his history, and you can pick this up when you download his program, VK3UM EME Planner. But I wanted to make a mention of one other use or two other uses that have been used of Moonbounce, and mainly by the military. First of all, you may be aware that before satellites, we were very interested in what was going on in Russia. And in fact, Russian phone conversations were being intercepted based on their reflection of those radio signals off of the moon by our Department of Defense. So big dishes were being aimed at the moon, and knowing the frequencies that they're on, they were copying moon frequencies. The first transmissions, some of the very first transmissions that were made actually for submarine communication. Again, without satellites, they come up and they have to put a big antenna out, and they were doing Moonbounce for submarine communications prior to the modern satellite era. So I thought that was kind of interesting, and hams jumped in there right at the beginning. The very earliest efforts were done by hams, and many of the records that were set in terms of some of the early things was kind of fun to read about. So let me just conclude my talk here tonight by saying that there are some who are planning to do a lunar crater radio telescope. Now, what would that look like? Well, you got the Earth over here, the sun here, the Earth here. There's Earth noise in here. But if you could get the antenna on the other side here, aiming out into space, and use that part of the moon, if you will, to listen to outer space, you could dramatically improve your signal to noise ratio. And the thought is that perhaps we could do deployable wire mesh, a suspended receiver here, a little bit like the Arecibo dish, I guess you might say, but I think this one is bigger than Arecibo, 3 to 5 kilometer diameter. I can't imagine how much gain that is. But I thought this was pretty cool. And once you learn the basics, you know, the basics of Earth, Moon, Earth, you can begin thinking about, you know, how you could do new and innovative things. And finally, I mentioned before that 10 gigahertz is being used by hams. Some people are using 24 gigahertz signals with relatively small dishes. But if you think about it, you really have to be accurately aiming. So we're talking about 0.1 degree accuracy to aim a 10 gigahertz dish at the moon and be able to make contact. So if you look on the internet, you'll find guys at 1 degree moon elevation making a contact from Australia back to California, for example, using just a hand steering type of a setup with some power on 10 gigahertz. So fun to think about. I think I'll probably stick on 1296 for now. None of these big 20 Yagi setups for 432 or 2 meters, you know, with all the attendant troubles. Keep it kind of small and compact. With that, let me stop and say thanks for the chance to talk to you, and I'll be glad to have any discussion or questions.
Hey, Jim, I got a question. How would you compare EME with just regular ham satellite, other than being much harder?
Well, you know, satellite signals are relatively strong. Like an FM satellite signal, you might say, oh, it's only 10 watts, but boy, you can really hear them. They're in so close. You know, they're really, it's not like they're, you know, let me just give you a comparison. The moon averages about 250,000 miles away. The round trip for your signal to go out and back is a 500,000 mile round trip. So 250,000 miles is a long distance. How far is a satellite away from us, right? Just, you know, a matter of miles, right? Maybe 100 miles, but not 250,000 miles. So that now you get thinking, gee, so the aiming, you know, is a whole different ball game. And we found that out. Most of us, you know, didn't have to be right on AA4MD as it came over, even at its elevation. You could sit there and make some adjustments in it by hand or with your rotors and talk to a guy in Europe for 5 or 6 hours with on the satellite going by on a 6 to 8 hour pass. Or if you do the same thing with your handheld and you work the FM birds, as you know, it goes over in 15 minutes. You got to be aimed at it, but you could listen to it just with hand aiming. So I think that's, to me, that's kind of the biggest thing. Plus, you know, you can use a handheld to work an FM bird, right? You know, I'm using the equivalent of your microwave, about 600 watts of microwave energy that will fry a hot dog in seconds, right?
That's cool. Any other questions? Anybody else have anything else? That's very interesting.
I did find the picture of the preamp builder guy there, Jim, from our trip to Dayton.
Oh, I see it behind you.
Oh yeah, okay. He's one smart guy. I've worked him a couple of times on digital, actually.
That's actually me and Dayton handing over one of Jim's failed preamps for him to take back.
I think I sent 2 or 3 with you, as I recall.
Smoking preamps, a shame on you.
Oh my.
That's a long story.
Oh man.
So Jim, let's assume that there's a big gun station over in Europe and the position to them doesn't matter so much for the purpose of the question. Where would you rather the moon be for your station? Let's assume the moon's above the equator, right? That the declination is positive. Where do you, just walking outside, where in the sky would you like the moon to be for your station?
Well, that's really very individualistic in terms of what your setup is. For example, when the moon comes up for me at 90 degrees or 100 degrees, like I say, I'm aiming at the airport, and I may have all kinds of radar beacons and other things, or I may have a little spot where it's kind of clear and not spilling over. I'm going to get some peripheral, some ground amplification at a very low So sometimes I work the guys at 3 degrees, 4 degrees here on the contest. I'd start out, and gee, by the time I was up at 4 or 5 degree elevation, which looks like the sun is coming or moon is coming up to you and I, but to us. But boy, sometimes you'll get a pretty good signal report, more than you'll really expect. And then I guess once you get up kind of overhead, it's a little more difficult, I think. But there's a huge advantage, I think, to get the dish up like I have it up about 25 feet and being able to go down to the horizon. Now, some of you might remember here as pictures that I was showing you here before. That picture, the tower didn't last very long, I can tell you. It came down within the first few weeks because if you're aiming out to the west trying to work Japan or something, you're aiming right at that other tower. So you really have to clear the deck, if you will. Reminds me of the first time I had the dish up and got it working. I went on the Facebook because somebody was over working with me on the dish, and I said something like "men playing with dishes" and on my Facebook site, and the neighbor across the canal came back and said, "Yeah, and it's aimed at me." So
you need to put a sign on it that said the AA4MD death ray. So, oh man. So I have a question. Is probably in 10 gigahertz is be more prevalent, but when you're at low elevations, do you get any effect from curvature of the earth or earth bulge or any of that kind of stuff like you get in microwave?
You get amplification. Yeah, I think of this low amplification. Now
There's
remember, you're going to have more noise. There's a lot of noise. There's kind of earth noise in your receive, so that may kind of cancel out any benefits you get on the transmission side. But I think there is some amplification at low elevations. And so I usually try to get on, be ready by 2 or 3 degrees to get on to talk to a guy in Europe, and those signals will come up pretty quickly if you're up like I am, kind of in the clear.
Yeah.
A lot of guys around Europe and other places that get on have trees, up until 17 degrees before they can even, or the neighbor's fence or whatever. So I feel very fortunate to be able to spin it pretty much all the way around. By the way, I don't run it all the way around 360. I run down to 180, and then by then I'm aiming up around 60, 70 degrees. I don't want to go much past 80 or so. So I bring it back down, go to 0, recalibrate, and then go back the other way if I'm going to continue on to a westward path.
But when you're shooting at low angles, other than amplification, you don't get any beam changing or more additional Faraday rotation as the signal goes through the ionosphere at a lower angle.
Well, I'm not on 1296. I don't think so.
But probably at 10 gigahertz, you get a lot of turning, or a lot of refraction through the ionosphere.
A lot of guys are linear on 10 gigs.
Yeah, that would make sense. So they're probably vertically polarized. So what you do, you right-hand circular polarization up, and then it comes down left-hand circular polarization for receive. So yeah, okay, I get you. Cool. That's neat. Anything else? Other questions? This is really interesting. I didn't think there was that much stuff to it. All I know is I saw a picture of this one guy in Texas, and he has this incredibly huge array that he uses a chassis of an old Ford truck as the base of the array, so it moves it around in a circle. It's his backyard. I think I forget, this guy's a W5BM or something like that. I saw a picture of that. That's insane.
Totally. Yeah, I mean, you see some of these big, they make big signals up on there and work. A lot of guys become the big guns, so to speak, of the frequency. But yeah, no, I didn't really know what was going to happen after my wife said, "Well, let's shoot the moon."
Oh my! Well, yeah, it's like I say, the guy has a big antenna in Texas because everything is bigger there. So anyway,
well, man thought it was just going to be one contact, and that would be done.
Yeah, yeah. There's more than that comes. I should tell Linda she should feel lucky.
We have perfect ham radio wives, right?
Right. Perfect. Yeah, right. All right. Well, anybody else have any questions? This is outstandingly interesting. This is like satellites only like times 100 because it
What
is the satellite.
And Jim, is
What
it
about-
practical to go up to even more power, like full legal power, or is that more trouble than it's worth?
You mean do a kilowatt, for example, on 1296?
Right, yeah.
Yeah, yeah. Well, the amplifiers that you'd use would have to be water cooled, so you'd be going back to kind of older technology. I probably could come up with, an 800 watt or 1,000 watt. You can put a couple of these things, these amplifier boards in series. Am I right about that, Tony? Can you unmute for a second and tell us how would you get more power on 1296?
You'd have to use
You put them in parallel.
Well, you have your two 600-watt amplifiers and just put them in parallels. That's 1.2 kilowatts. So are you using waveguide or coax?
Coax.
Oh, okay. So if you use waveguide, you'd have less loss.
Yes, that's correct. But and you have to do that pretty much at 10 gigs.
Yeah. Well, 1296, the waveguide would be like that big around.
big,
Right.
huge.
So I know where there's some of that. Just laying around in the field. Anyway. Any other questions?
How does this change when we talk about 6 meter Earth, Moon, Earth?
Yeah, well, what do they call it? The golden band or something like that? What's
The magic band.
The magic band. There you go. The magic band. 6 meters. There's some dedicated pioneers, if you will. They're out there on 6, and they'll do de-expeditions. Actually, they go off and somewhere and set up a 6 meter, huge Yagi, and put a lot of power into it. That's where you begin to see a lot of power at that little lower frequency at 50 megahertz. But I've never done it. Anybody who has a 6 meter antenna like I do up on your beam, you can work the moon at low elevation, spin your tower around, take a listen, or get your digital thing lined up. They use, I believe it's JT65A, correct me if I'm wrong, on 6 meters, but you can make a digital contact on 6 meters using your ham station with 6 meter information.
I got to try that. I've got 1,300 watts on 6 meters.
Whoa. Well,
You
you'll
said-
hear yourself.
Now you're talking to CW, but this is not CW as we know it. This is like slow speed CW, right?
Not
Oh yeah, you can
really.
make it
I was using 10 to 15 words a minute up there.
Oh
But
really?
if you're having trouble and it's really weak, it helps because of the slight. You see some QSB off the moon to slow it down, and most of us slow way down if we're having trouble communicating. That's right. If you haven't, just to complete the contact.
Yeah, because some of the software has that slow CW setting for it.
I've never used any software there. I haven't tried WSGT software for CW.
I've been planning on experimenting with some 10 gigahertz receiver and a 1 meter dish, and you use these standard LNBs like you do on the commercial satellite downlink, and they have noise figures sub 1 dB at 10 gigahertz. And if you take, I've got an SDR play, and if you look at the standard local oscillator signal, it's 9940 or something like that in your LNB. And if you want to receive 10.368, you tune your SDR play to 618 megahertz. And that's the way I check some of my 10 gigahertz transmitters and signal sources. And I've got this 1 meter dish out there, and I've got a crystal controlled TCXO LNB, which is stable enough for CW and the like. And they use it on QO100 over in Europe.
Yeah.
The 10.4 get downlink. And I've been intending to put that up and see if I hear some of the 10 gigahertz guys. You should be able to. I don't know. That thing is very good noise for lots of gain, 60 dB gain.
Yeah.
I'll probably have to put a attenuator on it. So
If I was going to try to get on and had unlimited dollars, I would go with about 30 to 50 watts into a 2.4 meter dish with 0.1, accuracy, and then the best LNA and you could buy, and put everything would have to be mounted right on the dish.
you can build air-cooled 50-watt single chip MMIC amplifier. They make them, and I've looked at in the Dubus magazine. I've got the article there for a 50-watt 10 gigahertz amplifier. I think it runs on 28 volts. I'm not sure. 28.
Well, why don't we go together and buy one, and you can have it, and I can have it, and we'll share it.
You make about
Do
5
do
times-
remote Moonbounce.
I'm on the verge of retiring, and you make more money than I do, man. You'll have to finance it or something. I don't know. Second mortgage a house. I don't know.
Well, where am I going to put it? I now have this tower with a 12-foot dish on it, and I've got to have where I'm going to want to be able to point to the moon. I'm going to have to just be at certain angles.
Al Ward used two 50-watt 10 gig amplifiers combined and did portable EME from out west somewhere. Al Ward, W5LUA, been in the microwaves for years. In fact, I think he's done EME on 24 and maybe 48. I'm not sure.
Yeah.
But he used two of those 50-watt amplifiers combined in a three foot dish, standard offset feed dish.
Yep.
And I don't know what kind of preamp he used, but obviously he had one at least as good as the LNBs, and he made some contacts from the back of his car with one of those 1 meter dishes and 100 watts on 10 gig. That was in the Dubus too. You might ought to try to subscribe to that Dubus, Jim. That's a pretty good.
Yeah, I was in the Dubas contest here. They run a contest in the spring, the Germans, and a lot of smart guys there, and they make there's a couple of commercial entities there. But yeah, let's both retire and put it in the back of the pickup truck, and start putting some of these states on the 10 gigs on the moon.
Anything else, anybody? Going once? Going twice?
Thanks, Jim.
Jim, thank you so much. This was, I'll be honest with you, this was really interesting, the stuff that you're doing. I didn't think it was this complicated. I remember one day you told me you were using a television camera with a toilet paper roll to line up the moon. And I thought, shoot, that's, anybody can do that, but it gets a little bit more complicated from the sounds of it here. So anyway, that's a great presentation. I really enjoyed it, and I hope everybody else did as well. And congratulations for your to shooting the moon. So that's terrific.
Thanks, very much. Great to be here.
I have nothing else unless Larry, you want to take over and go from there.
I have nothing other than saying thank you again, Jim. This has been fantastic.
Yeah, really.
We have recorded this, and Dan will get it up on our website, and you can review it and listen to it again or as many times as you'd like to. And so thank you all. This has been a great group and a great evening. So thank you for coming.
Thank you all for coming on.
Good night.
Good night.
Good, guys.
Take care, Jim.
Good night.